Today we're going to practice on how to fill out the Aufbau diagrams using the different electrons that we have available from different elements. So to do that, we're going to look at these three elements: beryllium, magnesium, and selenium as our examples. So in class, I was showing you guys that the different orbitals are given this way, and the sheets that I gave you in class start with 1s and they end at 6s, but we know that it actually goes to 8s, but just for these examples, we're not going to go all the way up to 8s. So let's go ahead and start filling them. A couple things to remember. In order to fill these into the Aufbau diagrams, you have to fill in each box with an arrow going up and down, denoting the spins of the electrons. And also you have to, just say I was going to fill in 2p, I would have to put in an arrow for each of these boxes and then go back and fill them. So Hund's rule states that you have to fill the sublevel before you go back and pair them up. Okay. So first of all, just like I gave you guys in class, you're going to write down the element. So I'm going to go ahead and write down beryllium. And the atomic number. So you need your periodic table for that. You find beryllium, and it's actually the fourth one over, Be, and the atomic number is right there. It's 4. So there are 4 protons, and in a neutral atom of beryllium, you also have 4 electrons. So go ahead and fill that in. So the atomic number is 4. There are 4 protons, and there are 4 electrons. Okay. We're going to write the shorthand electron configuration after we fill in the Aufbau diagram. Okay. So now that we know that there are 4, you're going to go ahead and try to line up this video camera. You're going to go ahead and put your arrows in. So one going up, the other one's going to be going down, denoting the opposite spins, clockwise and counterclockwise. Okay, and for beryllium, that's it. There are 4. So you count up. You're starting from the bottom of the energy level, 1, 2, 3, 4. Now you have to make that shorthand. So you would say 1s, and that there are 2 electrons. So you make a little exponent. So you write 1s, 2, and 2s, 2. Okay, that's brilliant. Nice job. All right. So we're going to move that over. Okay, the second one we're going to do, so very good. I'll finish beryllium. Magnesium. All right, so magnesium is over here. Oh, I didn't realize I just chose the one right below it. So magnesium has 12 protons, therefore 12 electrons. This is the atomic number. Okay, so I'm going to write this down. Okay, so atomic number is 12, so therefore it has 12 protons, and in a neutral magnesium atom it also has 12 electrons. Okay, so let's go ahead and fill these. So 1, 2, 3, 4, remember go across first, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now you might say, Ms. Burgess, it doesn't matter if we go across first because either way it's going to fill it. That's true, but in this case I would not just fill them because, in doing other problems, because you might forget. Okay, so 1s2 is our shorthand. 2s2, just as a reminder, I'm just looking up here. Okay, 2p, there's 6 electrons. And lastly, 3s2. Okay, there we go. Nice job. All right, magnesium's finished. All right, so the last one is selenium. Now, selenium is a lot higher up on here. So if you find selenium, we are over at 34. This is going to allow us to really use this chart. So this was given in class. It might look a little confusing, because it does look confusing. But this is just showing you the order in which you're going to fill your different orbitals, okay, your different sublevels, your different orbitals. Notice, once you're finished filling 3s, you fill 3p. Notice you don't fill 3d next. You go on to fill 4s first before filling 3d. So we're going to see that in this case. All right, so this is very helpful in the future, so you know what to fill before, the other orbitals. Okay, so selenium, again, we are looking at 34. So I'm just going to go ahead and write that. Okay, atomic number 34. So there are 34 protons and 34 electrons. I'm going to go through and fill them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31, 32, 33, 34. Okay, so notice I filled in 1s, 2s, 2p, 3s, 3p, then 4s. Then I filled in 3d and then 4p. So it can be a little confusing. Okay, but what is nice about these charts is it kind of, just by looking at the increase in energy level, you can kind of tell which ones you're filling in, because you're just kind of going, okay, well, what's the next boxes that come, above this one? Well, above 4s, looks like a 3d, and then a 4p, okay? So let's go ahead and fill these in. So 1s2, 2s2, okay, I already know it's going to be 2p6, okay. 3s2, 3p6. Okay, remember after that, you're not going to write 3d yet, you're going to write 4s. So 4s2. I'm starting to run out of room. And 3d, this time, you have how many? You have 10. So 3d10. Trying to hold the video camera too. And just to kind of help with saving room, so you guys can actually see it, put on here. So after 3d10, okay, you have 4p. And notice you're only putting the number of electrons that are actually in there. So as you can see, 4p can hold 6, but in this one, you can only hold 4, okay, in terms of this specific element for selenium. So 4p4. Okay, there you have it. So those are our 3 examples. If you guys need additional help, you can make an appointment with me. But that was Chapter 5, Aufbau Diagrams. Thank you.